Welcome everyone, and thank you for joining this session on database test conditions. My name is Jogul Sarwar, and I'll be guiding you through the essential concepts that software testers need to understand when working with databases. In this series, we'll explore how to identify and apply test conditions that help ensure data accuracy, maintain integrity, and verify system behavior under various scenarios. Whether you're new to database testing or looking to sharpen your skills, these insights will help you design effective tests that catch issues early and keep applications running smoothly. Let's move to the next slide where we will discuss the fundamental types of database test conditions and how they relate to real-world testing challenges. Using a checklist for testing helps ensure that no important steps or conditions are missed during the process. It acts as a guide to systematically validate different aspects of the database, such as data accuracy, integrity, and how the system handles various operations. By following a checklist, testers can maintain consistency, reduce errors, and make the testing process more efficient. This way, even complex scenarios are thoroughly covered, which helps catch issues early and improves the overall quality of the database system. Let's move to the next slide where we will discuss specific test conditions that are crucial for effective database testing. Using a checklist during database testing brings several important benefits. First, it helps ensure that all client requirements are fully covered, which means nothing critical gets missed during testing. This leads to enhanced accuracy and fewer oversights, reducing the chance of errors slipping through. Additionally, a checklist promotes better coordination across different teams involved in the testing process so everyone stays on the same page about what needs to be tested and when. It also provides clear visibility into the progress of testing and the coverage achieved, making it easy to track what has been completed and what still needs attention. Altogether, these advantages help testers validate data accuracy, maintain data integrity, and confirm system behavior matches expectations more effectively. Let's move to the next slide where we will discuss specific test conditions for database testing. Let's move to the next slide where we will discuss the checklist for database testing. This checklist serves as a practical guide to ensure all critical aspects of the database are thoroughly tested. It helps testers systematically verify data accuracy, integrity, and the behavior of database operations. Using a checklist reduces the chance of missing important test cases and makes it easier to track what has been covered. It also supports better coordination within the team by providing a clear and shared reference point. As we progress, I'll walk you through specific items that should be included in this checklist and explain how each one plays a role in validating the database's reliability and performance. When validating a database, it's important to ensure that the data between the database and the client or web interface stays in sync. This means that when you run queries or use views and stored procedures, the results should accurately reflect the current data. Testing also involves checking all data manipulation operations like updates, deletions, and inserts to confirm they work correctly and don't cause unexpected changes. Performance is another key aspect. Queries and transactions need to run efficiently without slowing down the system. Additionally, you should verify that processes for maintaining the data, such as backups and recovery methods, are reliable in case of failures. Finally, checking data integrity and security helps ensure that the data remains accurate, consistent, and protected from unauthorized access. Altogether, these checks help testers confirm that the database functions as expected and supports the overall application's stability and trustworthiness. When testing at the system level, it's important to simulate real-world scenarios like service failures to see how the database behaves under stress or unexpected conditions. This helps ensure the system can handle issues without losing data or crashing. Optimizing performance through indexes also plays a crucial role, as it speeds up data retrieval and keeps the application responsive. We need to verify that all events, such as errors or transactions, are properly logged to the event or trace log, which is essential for troubleshooting and auditing. Checking the naming conventions for database tables might seem minor, but consistent and clear nomenclature helps maintain clarity and reduces confusion when working across teams. Testing database operations under various conditions, like simultaneous access or large data loads, confirms that the database performs reliably no matter the situation. Finally, security is a top priority, so we assess connection strings to ensure they are secure and run tests against SQL injection attacks to protect the database from malicious threats. Altogether, these system-level tests help validate not just data accuracy and integrity, but also the resilience and security of the entire database environment. Testing data integrity, it's important to first confirm that each column in the database uses the correct data type, like numbers where numbers belong and text where text is expected. This helps prevent errors and keeps the data reliable. Next, we want to check that the data is logically organized within tables, ensuring that related information is grouped properly for easy access and consistency. It's also crucial to verify that data is stored in the right columns. Sometimes incorrect placement can cause confusion or inaccurate results when querying the database. At the same time, we should identify any irrelevant or unexpected data that doesn't belong, as this can indicate problems with data entry or system bugs. Evaluating data encryption measures ensures sensitive information is protected, which is vital for security and compliance. Finally, testing the database's response to invalid data inputs helps us confirm that the system handles errors gracefully without corrupting data or crashing. Together, these checks help maintain accurate, trustworthy data and keep the database operating smoothly. When testing data fields, it's important to prevent null values in critical areas to avoid incomplete or inconsistent data. For example, primary keys and foreign keys must always have valid values because they establish unique identities and relationships between tables. However, there are cases where allowing nulls is necessary, such as optional fields or when data might not always be available. Defining which fields are mandatory, especially in dependent tables, helps maintain referential integrity and ensures the database behaves as expected. Validating the logical structure of tables means checking that the relationships and constraints between fields make sense and support the overall data model. These checks help catch errors early and keep the database reliable and accurate. Let's move to the next slide where we will discuss system-level testing in more detail. When working with procedures and triggers, it's important to confirm that any data changes they are supposed to make actually happen after the procedure runs. This means checking that procedures activate as expected when certain events occur, and that they respond properly if something goes wrong, like handling errors without crashing the system. You'll also want to carefully review the input parameters to ensure they're valid, and see how loops inside the procedures behave, making sure they don't cause infinite cycles or miss critical steps. Testing these procedures manually gives you a good sense of their behavior, but using profiling tools can help identify performance issues or hidden errors that manual testing might miss. Together, these steps help maintain data accuracy and system stability by ensuring that procedures and triggers work smoothly and reliably. When we talk about integration tests in the context of database systems, we focus on how different parts of the system work together, especially when handling user data. One critical aspect is verifying that user data saving functions operate correctly, which means ensuring that when data is entered, it's properly stored without errors. For example, testing null value insertion constraints helps us confirm that fields meant to be mandatory don't accept empty or null values, preventing incomplete records. We also check data consistency and integrity during user queries to make sure the data retrieved matches what was saved, maintaining trust in the system's accuracy. Another important area is handling transaction limits, which involves confirming that the system manages large or complex transactions without failures or data loss. Lastly, Validating Unicode support and field boundary constraints ensures that the database correctly processes a wide range of characters, including special symbols, and respects the limits set on data fields, like maximum length. These integration tests are essential to catch issues early and ensure that the entire data flow, from input to storage to retrieval, works smoothly and reliably. Let's move to the next slide, where we will discuss performance testing and how it impacts database efficiency. Now that we've covered system-level tests, data integrity, field tests, procedures, and integration, let's look at some practical examples. These will help you see how the concepts we've discussed come together in real testing scenarios. By applying these examples, you can better understand how to verify database behavior, ensure accurate and consistent data, and confirm that all components work as expected under various conditions. This hands-on approach makes it easier to spot potential issues early and maintain a reliable database environment. Let's move to the next slide, where we will explore specific case studies that illustrate these testing principles in action. To make sure the data you see on the client side matches what's actually stored in the database, it's important to check synchronization carefully. This means when a change happens in the database, like updating a user's information, that update should appear immediately in the client interface without delay. Automated tests are really helpful here because they can simulate different situations and confirm that the data stays consistent across the system. If there's any mismatch between what the user interface shows and what's in the database, these tests help spot those discrepancies quickly. Additionally, by implementing logging, you can track any synchronization problems as they occur over time, making it easier to identify patterns or recurring issues and fix them before they impact users. This approach not only keeps your data accurate, but also builds trust in the system's reliability. Let's move to the next slide, where we will discuss another practical example to further explore these database testing concepts. When testing data updates, it's important to confirm that changes to different types of data, like text fields, numbers, and dates, are handled correctly by the system. This means checking that when you update a record, the new information actually saves and remains consistent, even if you close and reopen your session. You also want to make sure that any rules or constraints, such as required fields or value limits, are still enforced after the update so that data integrity isn't compromised. Additionally, it's crucial to observe how triggers and logging behave during these updates to ensure that any automated actions or audit trails function as expected. This thorough approach helps database testers verify that updates are reliable, accurate, and maintain the overall health of the database. When verifying query results, it's important to make sure the queries not only run without errors, but also return the exact data you expect. This means testing simple queries that might just pull a few records, as well as more complex ones involving multiple joins or conditions. Using test datasets helps us confirm that the query logic works correctly and that the results match what the data actually contains. It's also crucial to check that queries are safe against SQL injection attacks by validating inputs and ensuring no malicious code can alter the database. Finally, assessing how queries perform when the system is under load gives insight into whether they will remain efficient and responsive in real-world scenarios where many users might be running similar queries at once. This thorough approach helps maintain accuracy, security, and performance in database operations. When testing how a database handles unexpected errors, it's important to simulate different kinds of disruptions like service interruptions to see if the system can recover gracefully. We want to verify that data recovery mechanisms kick in properly after failures, ensuring no loss or corruption occurs. This includes checking that backup and restore procedures work as intended, so data can be restored to a consistent state when needed. Additionally, it's crucial to observe how the system behaves under stress, such as during high load situations or when storage space is running low, to make sure it can continue operating or fail safely without causing bigger issues. These tests help confirm that the database remains reliable and resilient, even in adverse conditions, supporting overall data integrity and availability. Security testing is a crucial part of validating that your database and application protect sensitive information properly. One key step is to check that the security models in place, including user roles and permissions, are correctly defined and enforced. This means verifying that each user only has the access they need, nothing more. For example, cross-checking database access levels ensures that someone who should only read data cannot accidentally update or delete it. Implementing role-based access control properly helps maintain this separation of duties effectively. Beyond permissions, penetration testing is vital. It simulates attacks to find vulnerabilities before a real attacker does. Part of this involves inspecting connection strings to confirm they use secure authentication methods, like SQL or Windows authentication, without exposing credentials. It's also important to test how the system behaves when someone tries SQL injection attacks, which are common attempts to manipulate or extract data through security loopholes. Running these tests helps ensure that your database is resilient against unauthorized access and potential breaches, maintaining the integrity and confidentiality of your data. Let's move to the next slide, where we will explore another important aspect of database testing. Here, we see a collection of diagrams that help us understand the database structure more clearly. The first diagram shows the overall schema, which outlines how tables are organized and connected. This helps testers see where important data is stored and how different parts relate to each other. The next diagram focuses on entities and relationships, highlighting tables, fields, and keys. Is crucial for identifying how data links together and where primary and foreign keys enforce integrity. Finally, the normalization levels diagram illustrates how data is organized to reduce redundancy and improve consistency, moving from first to third normal form. Understanding these levels helps testers verify that the database is well designed, which supports accurate data updates and efficient queries. Together, these visual tools are essential for anyone testing databases because they clarify the structure and rules that keep data reliable and consistent. Thank you for staying with me through this presentation on the importance of thorough database testing. As we've seen, checking every aspect, from updating records accurately and verifying query results to handling errors gracefully and ensuring strong security measures, is essential to maintain data accuracy and system reliability. Visual tools like database diagrams help us understand the structure and relationships, making it easier to spot potential issues early on. By carefully designing tests around these areas, database testers can catch problems before they affect users or business operations. I hope this has given you a clear picture of how comprehensive testing supports a healthy, secure database environment. Please feel free to reach out if you have questions or want to explore any of these topics further. Stay curious and keep learning.